So we're going to start with a quick introduction. We need to know who we are and why we are here. So we are part of the European Association of Geoscientists and Engineers. Thank you. It is a non-profit organization created in 1951, full of professionals, young professionals, or just people that are interested in the topics of geoscience and engineering. Our main goals are to promote the development, innovation, and application of geosciences and related engineering subjects, and to foster the communication, fellowship, and cooperation between people working in studying or otherwise just interested in these topics. Even though we are mostly located in Europe, we also have members all over the world in all the continents. And every year we do our annual conference and exhibition, this time in Oslo, Norway. You are always invited to attend. Most of the companies and most of the people here already attend to these events or presented in these events already. And this year we also have the near surface Geoscience 24. It's going to take place in Finland in September. So another event that the global organization does, and you are also invited to participate. If you become a member or renew your membership to the global organization in this end of the year, you're going to get access to all the benefits. For example, this beautiful First Break magazine that I received has all the other members at the beginning of each month with papers, articles, and information about the topics that we are all interested in. To talk a little bit about us, the local chapter Paris. As I told you, we have communities members all over the world, mostly obviously in Europe, since we are the European Association, and that's how we started. We renew after a 3 years of a great generation of professionals that manage the chapter. We renew our board in the beginning of this year. We started with just 3 people, and now look at us. We are a full team with operational members helping us in different subjects, and we're still available if you want to join us, if you want to help, if you have ideas for subjects. We are always open to new members. We did start slowly. You can imagine 3 people starting the chapter. So we started with an event with our friends from the ESPE. They led us in their event. So that was our first event of the year. Then we tried to do one event a month. And in the month of May, we did 2 events. It's kind of good. And then we take a summer break and we started once again. And this is our last event of the year. 5 speakers, a really interesting subject, and we are not finished yet. 2024, we will start with new subjects: data acquisition, hydrogen, career challenges in geosciences, planetary seismology seminar, and many more to be confirmed. You can follow us in LinkedIn to see what we can offer you in the next year. And just to finish,
The activities that are linked to the oil production and gas production. So do not hesitate to join ASP activities, and we will switch and also know what's happened and at the global level. So here in France, we have the ASP session that is represented by more than 5 big and petroleum and petroleum services company as Total. Our president comes from Total, and a third of our members come from Total. Then we have the representative. This is a board members, very well-known society as Technip, Subsea 7, all aspects and all, even SP school are all represented in our boards. So do not hesitate to look to our LinkedIn web and see what's happened, because a lot of activities is organized by not only our section, but SP, but our section organize the monthly conferences, the networking events, the partnership and collaboration. And today you can see the good example of the well-organized events together. We so it's our sister associations, and we also provide a lot of student support, because we provide the financial support for the field trip, for Petrobol, and annual participation in the annual worldwide conferences. This year, for example, we sent 4 students in the United States in Austin. So our next event, it's a good place to say that we organize the online conferences, and don't hesitate to, if the subject are interesting for you, to join us for geothermal talk. It's a technical talk, and we will talk about digital rock physicists. It's a Total representative who will so don't hesitate. It's only for 45 minutes technical talk. And our biggest event will come in next year. So we will celebrate our 14th anniversary. So we start from now to organize these big events. Eventually our sister association will be invited. So don't hesitate also for us. We also will ask the SP president to come, SP European representatives to come. So it will be big events for the next year. So our sponsor, as well as our participants, are there, as I have already said. And so I don't want to lose more time. And so we are welcome to start today's conference.
Great, thank you so much. Okay, so let's get into the main topic of tonight's meeting. Thank you again for the speakers for attending and joining us tonight. And I also want to thank everyone that joined us in person as well as on Teams. Tonight's topic is about minerals for the energy transition. It is our last event of the year. We have plenty to come next year, but again, really excited about tonight. As you can see here, we have several topics. We're going to try to stay on time, and I will be monitoring the different presentations. So with that, starting with our first speaker, we have here Emmanuelle Robin here in person, but then Jérôme Gouin is online from Avenia. Looking into Jérôme Gouin's bio, Jérôme is a PhD in geology. He worked as a metallurgist at BRGM, specialist on deposits in ore deposits in Europe, Western and Central Africa. He also worked as a project manager for gold exploration in France at Variscan. And then right now, he's a project leader, mining and quarries, civil engineers at Avenia. Emmanuelle Robins has a master's degree in European projects for territorial development. She's a chemical engineer with the BS Hans at Kingston University. She's a project leader, Europe and international at Avenia, and she is expert in transcultural projects. And so with that, Emmanuelle, I will let you go ahead and present on your topic. I will change the slides. So give me just a minute.
Good evening, everyone. So I know that some of you are a bit disappointed that Jérôme is not attending, but he's here as well with us online. I will be presenting Avenia in general, which is a non-profit organization like EAGE. And the purpose is to boost innovation through collaborative projects on the territory, which is originally centered in Pau, southwest of France, but now we have members all over France and also in other countries in Europe and in Quebec. Our missions are really to contribute to the competitiveness of the subsurface and make sure it's well into the energy transition, and also assisting and structuring the structuration and the promotion of the sectors at different territorial level. Territory is a very convenient word because it has no boundaries. You can place it wherever you want. And as I said, it's to make sure the subsurface is within the ecological and environmental energy transition. Originally, the focus was on oil and gas, but we've now extended the activities to geothermal energy, the geological storage of gas, so it could be CO2 or hydrogen, mining and quarrying, hydrogeology and geotechnics. We've decided to address some of the topics through programs, and the one I'm going to focus on tonight is one called Alina, which Jérôme and I both lead, and it's really to put the raw materials in the energy transition. Why it's called Alina? Because originally it's the A for Avenia, Li for Lithium, and Nouvelle-Aquitaine. But this is the first topic that we wanted to address, which is not restricting to the. This is not a restriction, and really we want to address any metals or materials. And secure the supply for the industry of the future, we call them. So it could be digital, microchips, batteries, and with the will to do that in a responsible way, because we want to promote the green energies, but of course producing green energies with materials coming from non-green environment or production. That's not something that we want to push. How are we going to do that? We would like to boost the local ecosystems through innovation, taking the whole value chain within the in the frame. So that could be from exploration to exploitation, taking into account the environment, the circularity of the materials, and include as well the end users. So really, we want to contact the battery industry, for example, and include them, because it's not only the subsurface mission to include the materials in the new in the industries, but also the industry responsibility to include responsible materials. We have also included the social acceptance criteria. So we have a working group between all the activities and the sectors that we address. So because all the subsurface projects have the same issues of social acceptance, we want to include as well the training and the environmental impact. When I say training as well, it's for the new generation as well as the continuous training. For this, we have developed a lot of collaboration with other countries in Europe that you see on the top right map, and a strong collaboration as well with Quebec. And we were actually in Quebec 2 weeks ago to increase that, and especially the collaboration on a win-win basis. So because also Quebec is speaking French, they're really North American. So each time we go there, say we have collaborative project, they say where are the dollars? But we have strengths and they have others. So we want to have this win-win collaboration. And this is actually something that we want to duplicate to any of the collaboration that we have. We want to so we have this new communication group that has started regarding the social acceptance of the project, but also we have some members coming to see us saying, I have an idea, for example, of valorization of tailings, or we have some old book saying that we have some resources in the ground, and we have the mapping that we currently have at the moment, and how could we include France or other countries in Europe to secure the supply chain for the industries. This is what we want to include and promote. I don't know if we can have a connection with Jérôme. Maybe he's got something else to add, or unless you have questions.
I don't know if it's possible to hear me. If it's not good, I could write something in the chat.
I forgot to say that the members that we have more than 260 members now. They are large companies, SMEs, probably 60% of them. And we have research labs as well, towns, the region as well, or some regions. We really want to imply the politics in the project as well to support the project. He's here. Yes.
Can you hear me in Paris?
Or maybe you can add something in the chat and we can have a
Okay.
look later on. Yep. Responsible mining, yes. We have the potential for this. Moi, oui. Well, Avenia has been a partner in a group of a project called GFIS on social acceptance, and now GFIS is well, it's finished, but we are still in the discussions to see how we can move on, and we're closely following all the groups working on this at different levels, so very research level. But the group that we've just started is more practical. So we have people from the oil and gas industry regarding exploration, for example, for hydrogen, natural hydrogen, and really it's to make sure they share the experience they have on talking to the people. So it's not research groups. It's not research group. It's more practical. No, sorry. No. Originally, we need to start somewhere. So we started with the lithium in Nouvelle-Aquitaine for the batteries, but we want to address any material, not only Nouvelle-Aquitaine and not only this material. That's why we have the map with the resources available and what could we do next. So again, when I say lithium, it's not only in brines. We want, well, the original purpose was to use the lithium rocks. Merci. But also we need to get in. Well, Romain is going to speak about the geothermal lithium. That's included in the program, but it's just one part of the program. By the politics, the citizens, for example, people. We have some people growing crops on the field, and then there's permit on this field. How we can speak to these people to explain that the crops is very important, but maybe the underground is even more important for the whole population. So that's how to address this subject and say this is very important for the future. Not us, no. At the moment, we have this group of people addressing directly to the people, and they discuss together to make sure they have the good practice to speak to the population. And when I say population, it could be the citizen, it could be the politics, it could be people delivering the permits. Our members have direct contact with the government, for example, and for us, it's more with the towns or with the region. We also have connections with the government, but it's more to speak for our members. On the generally speaking, if it's a specific permit, then our members requiring this permit will speak to the government, for example. And we have connections as well in at the European level to discuss. And again, we as Avenia, we represent a community more than speaking for ourselves. And because we have so many SMEs, sometimes they don't have the time or the resources to mention. Maybe, for example, a legal problem could be an issue, and that's something they ask us to speak for them as a collective voice.
Okay, our next topic will be with Christian Polak. Thank you again for joining us today with Orano. Christian is an engineering geologist, graduated from the National School of Geology, Nancy. He worked as a senior advisor at Orano Mining, or currently working. He is a chairman of the Council of National School of Geology. He's also the chairman of the uranium group of the International Atomic Energy Agency. And then he's expert in uranium mining and processing consultant for rare earth and critical metals. Thank you again for joining us. Let me change it.
Thank you very much. So I first thanks the EAGA to invite me and to give the opportunity to talk about uraniums and uranium mining, and especially the size of innovations. And after I will review a little bit some topics about the resource reserve and the market as well. So that's one. Yeah. Okay. So first, a few words on Orano Mining. So Orano Mining, so it's a French company, it's a French state company. As you have to understand that sorry, could you remove the black panels? Sorry. Yeah, it's a state company, so you have to understand that in the country of France, 75% of the electricity is nuclear origin. So it's very strategic for France to keep the know-how to develop uranium mining on all the cycles up to the production of fuel, nuclear fuel. So Orano Group is the revenue. It's for 2 billion euros. So we have 17,000 employees around the world, and we consider that's the number 3 in the world. So we are covering all the topics. That's the pointer is here. Yeah, no. Yes, yes. Yeah, we're starting with the mining, and then we are doing what we call the conversions, chemistry, to transform the uranium yellow cake into the UF6, and then after doing the separation enrichments to enrich the uranium in uranium-235, because in the naturals uranium you have only 0.7%, and to be used in the nuclear power plants we have to move to at least 3.54%. So we are doing that in the enrichment processing. And then after, we are managing also the spent fuel after the reactions, because you have still valuable product inside. You have still 1% of uranium 235, and you have a plutonium and such metals we can recover on depleted uranium. We'll see that's a potential for the future. So we are doing around engineerings. We are doing the service of the nuclear power plant as well, and also the dismantling, and also we use also some of isotope for the medical purpose. Don't work. Okay. Okay, understand. Sorry. Yeah, fine. Now it's good. Thanks. No, specifically for uranium minings where I am working, we are covering all the mining cycles, meaning we are doing our own explorations. We are also working with other company, and we are developing the mining project by ourselves. We have engineering inside, but we also can use engineering company outside. We are developing our own extractions process. We have a center in center of France, in the Limousin, close to Limoges, a center we call the CIM. It's a center of metallurgy, mineralogy, to develop a process to extract uraniums. We have about 80 people working there. And after, of course, we have to review as a responsible miner. We have to look at for the rehabilitation of the site. And for example, in France, as we exploited during 75 years uranium in France, we have to rehabilitate about 250 mining either open pit or underground to rehabilitate and to restitute this mine to the public. So you have to review that's the timing is important in the mining. 15 years to generally from the exploration to the mining. The mining as long as we can from 10 to 15 years, and after rehabilitation is story of 10 years. So it's a very long story, the mining. So we are here for a few generations. So where we are as Orano, we are exploiting uranium in Kazakhstan. As Kazakhstan is a world producer of uranium, is producing 40% of the world uraniums. So we are here with a joint venture, GATCO. We are in Niger. We are developing. We are producing uranium from an open pit. As 2 years ago, we closed the underground mines, and now we are also in Canada, in the north of Canada, in Saskatchewan, where we are partner with. Another company, a Canadian company, but we have our own plant where we are transforming the uranium ores. So now I will talk about innovations. Some innovations in the very original technology used in uranium mining, and especially the uraniums is produced from 0.01% to few 10%. I think it's the only metals that we can produce of such a range of grades in the ground, from 0.01 to few 10%. So the few 10% are specially localized in the Athabasca, in Saskatchewan, in the Canada, where we had to develop a special technology. So this technology is the freezing technology. Why we freezing? So you have to imagine a bath tube full of water. That's a basin. The Athabasca basin is deep like 1,000 meters, and we have a mine on the flank of the bath tube. But the mine, the deposit, is just between the cast iron and the enamels. So you can imagine that is very sensitive to if we are crossing the enamels, we have our mine totally flooded, and we had this time 2 times. So we had to develop a special technology. It's only regarding uranium and only regarding this basin in Canada, where we are freezing all around the deposits with special brines, and where we can exploit the uranium under this cover. So it's a special technology we developed in Canada. So we call it jet boring, meaning so we have a level of the frozen level on the bottom, where we are injecting some we are injecting some brine above the deposits, and like that we protecting the deposit. And then we have a gallery added specially where we have equipments in order to drill and to it's like a Karcher. We are injecting high pressure water to destroy the rocks and to make a sort of slurry and pumping the slurry, and after evacuate the slurry full of uranium ores. And then after we feed up the holes, and we move like that step by step, covered by the frozen level. So the frozen level, so you can understand the way on this slide. It's we put a barrier. That's mean in the green. It's the interface between the I would say the water of the bath, and here the cast iron in green. If we can then give us some imaginations on all deposits just at the limit here in red, in red, and we are doing a sort of protections to avoid the waters entering into the mines. And we can do that differently depending where the ores, the deposit is located. And then we can drill from the bottom, from the top to the bottom, or from the bottom to the top. It's the difference, the technology of boring. We call raise boring or box hole boring or jet boring, where we're using the high pressure water to destroy the ores and to move step by step and to extract all the ores. So you have to imagine also the deposits are not so big. So uranium is very high concentrated here. We have few 10%, and the largest deposit of Athabasca is long like the Champs-Élysées. It's very short. So that's been his exploitations. That's probably 20 years normally we have to move for another exploitations. So that's the technology we can see here. You can see the injectors of here of the cold water. You see everything is frozen, and here the drillings, borings. So the machine is moving from the bottom to the top, and then here we injecting from we are drawing this machine from the bottom to the top in order we have a sort of trépan like in the petrol industry to destroy the rocks, and then after the rocks is pumped and into as a slurry into the external sinks. Another technology we are developing is like a mosquito technology, but it's from the top, because a lot of pockets of uranium are very compact. That means some uranium, they are like deposits, they are like this room. So when you have 10% in this room, it's very interesting to recover. But when it is at 200 meter, at 150 meter, we are not going to put an open pit to extract this uranium. So we imagine a special technology we call the saber. That's it's a drill from the top, and we are pumping. We are injecting high pressure water, and we are pumping the slurry from the top. And step by step, after we are extracting all the uranium from the pocket. So it's very exciting technology. Like that, we have no open pit, no tailings and everything. It's just from the bottom, and we move step by step without damaging the environments on the surface in the way of open pit or adit for decline to go underground. So it's technology in development. Other technology, which is mentioned Kazakhstan. It's the first world producer, and they are using the technology of in situ recovery. It's very original. It's only was used on sometime for copper, but mainly used for uraniums. It's a technology that use injections from the top of solutions that dissolve the uranium in the bottoms. Inside, we are pumping the solutions rich in uranium, and then fixing the uranium on the resin, and after sending the solutions again on the underground. So to do that, we need to be in the aquifer. It must be in the water, and we are protected also on the top, on the bottom, by the impermeable layers of mud. Like that, we are controlling totally the dispersion of the water. So this technology, so as you understand, for Kazakhstan, 40% of the world production. But if we add the country like Australia, US, or Uzbekistan, is more than 50% of the world productions is using this technology. So once again, no open pits, no underground. It's just, I would say, the story of a plumber. On the surface is a pipe. So the network we are using, it's easy, as we are injecting on the hexagonal side, and we are pumping on the bottom like that. So the solution we are injecting are not going away, but we are controlling and pumping all the solution in the middle, which is enriched in uranium, and then sending to the process fixing and after re-injecting. So it's like hexagonals, like a bees system. And we are moving step by step to following the deposit. So now, as I told you, that's the beginning. We starting with very high grade, at few 10% in Athabasca, but we can also develop it. We also developed some technology with very, very low grade, 0.1%. We are using a technology we call the heap leaching, which is also used in the copper for very low grade. And this technology is quite simple. So we put the ore. We make an agglomerations of this ore, and after we stack the ore in the heaps, and then we are putting some acid leaching or alkaline leaching. And under we are pumping the circulating the waters enriched with uranium, and then after we are going to the solvent plants and fixing the uranium. So that's a typical view of the heap leaching. So it's very large installations. It's a few hundred meters, 10 meter high, and we are moving step by step. As far as we are treating the ores, we put the tailings behind, and we are moving. So we are doing also with alkaline. Here is a view in Namibia, where we build a desalination plant to bring the water in order to use. So you can see the tube is like for the plant. We are doing a drop in order to infiltrate the heap, and then on the bottom we are extracting the uranium solutions. So now, yes, I'm still okay. Just controlling. Just a few view about the uranium markets. Because you understand that, especially with the COP28, nuclear is back, thanks to the fact that it's a very low carbon energy, and as we need it if we want to achieve the COP28 and COP21 targets. So uranium forecast is quite very encouraging now. So here is the productions of, I summarized the production of uranium for the last, since the World War II. We have a big peak here in the beginning. It was for military purpose. The productions increasing a lot, and then after the people, they did not know exactly how to manage the nuclear cycle, so they're producing a lot. Before here, this curve is a consumption of the uranium for the nuclear power plant. So you see that we at the beginning we produced a lot, but very quickly we had a huge stockpile, and you have detrimental events like 3 Mile Islands that stop the progress in US. We had the accident in Chernobyl, and then after Chernobyl, the lot of program were frozen, meaning the uranium was exploited before was used at the periods when the nuclear grows quite slowly, but continue to grow. And now, after the end of this stockpile, we're restarting the productions. And then we had the accident of Fukushima, and then once again it was frozen, and now again we are restarting the story, meaning so we need more and more uranium in the future. So you can pick up here the production in different countries. As I mentioned, Kazakhstan is the biggest one. You can pick up the size, and after you have the Australia, Canada, Namibia, Niger, Russia, and other. One point you can note that there is not Chinese. That's a chance for uranium markets, as the Chinese are very little producer, so they have to import. So they need to discuss. We want to invest outside the country. So we can plan for the next 10 years. That's the productions in the 30s will decline. And then we have to invest a lot now to develop a new mine to continue to fit. As you pick up here, there is a lack of uranium, so we need to develop a new mine to fit with the consumption for the nuclear power plant, and especially as the program are moving very, very quickly. So now the question is, do we have enough uranium? Uranium is a special metals. It's the only one where you have a group at the IEA, the International Atomic Energy Agency, where all the countries declare the resource or the reserve. So it's collected in the one book we call the Red Book. It's where all the countries are declaring the resource reserve, meaning like that we have a good idea of what could be the future. So it doesn't exist for the copper, for the gold, for the zinc. It exists for uranium. So it's an advantage, but also it's a disadvantage because the people say they are thinking that it's a finite resource and say, well, you have only that. No, as you pick up here between 2005 and 2018, you have a big jump in the resource. Why? Because at this time there was a lot of exploration. That's mean when you have exploration, you increase the resource on reserve. And when you see the resource around the world, you have the largest one is on Australia, and it is almost one deposit, only one deposit, controlling 25% of the world. Meaning such a deposit we can find more in Australia and other parts in the world. So that's exciting for the future. We know that such a targets we have to look at, and you can see that there is not so many countries involved in the uranium. So you have Canada, Australia, Kazakhstan, Namibia, Niger, but you have a country like Russia, which is a huge continent, that it's only limited because there's only the limited size of the country. So on the other, you have, for example, South Africa. It's a little one, but the continent like South America is almost not explored. So Brazil has a huge chance, Argentina and so on. So you have a huge chance to develop a new resource of uranium. So that's the story of the explorations. More you put money in the grounds for exploration, more you get some resource and reserve. So, and then if I'm talking at the end of the century and beyond, and then you have the uranium I told you at the beginning, that we are only using the uranium-235 and not the 238. And the 238 is 99.7%. That's the energy of the future, because this uranium could be used in what we call the Gen 4. It's in the fast breeder reactor, where we can use this uranium and activate this uranium to use this energy include. So meaning using the uranium-238 is multiply the resource by 140, meaning it's a huge resource for the future. And look at the world stock of this uranium today. The France, we have 400,000 tons, meaning it's equivalent of 56 million tons of natural uranium today. And you just pick up before, the IEA has 8 million tons declared in the Red Book, meaning France has the energy for 1,000 years if we want. So on this uranium-238 is the future of the nuclear energy for the next century. So we have enough uranium for today, for this century, and beyond, we have enough uranium for the next generations. So thank you.
On the page 9, you show the resources that known or explore. Yeah. I think. Oh, it was not. So anyway.
It's the one of
another.
IEA. Don't just give me that. I see. Yes. Okay. Identify resources. Yeah. This resource were qualified but already by explorations. Yeah, exactly. Beyond that, that's here I put the known characterized by explorations. So they could be defined by the resource reserve codes by the Australian core JORC or any 43101 Canadian core or Russian or South African. But beyond that, you have what we call unknown. That's you have also byproduct as uranium from the phosphate, from the copper. So you have a few possibility where uranium could be recovered, but is not included in this number. This number is known today. That's exactly that. You can see this this level of qualification.
Another question from the public.
Okay. What about France and Europe? Any reserves, any potential there?
Yeah, for sure. So France is we expected in the past 75,000 tons of uranium. Today is a depleted deposit, but we could continue to explore in France, but maybe deeper under the deposit we exploited in the past. And for the Europe, you have some huge potentials in the Scandinavia. In rocks we call the black shells. The grade is quite low, 150 ppm, but the resources are huge. And if we are extracting this uranium from Sweden or in Finland, we extract also other valuable metals, typically battery metals, nickel, vanadium, cobalt. One mines in Finland is producing today nickel, cobalt, and next year they will start to recover the uranium from these exploitations, meaning the restarting the mine in the uranium mine in Europe.
Another question here.
Thank you for your talk. I'm actually curious to know more about the economics of in situ recovery and whether you see that being used in other critical minerals besides, say, uranium. Is there even a possibility?
Yeah, no, it's very economic. It's the reason that 50% of the world production use this technology, because as you understand, there is no open pit, no underground, meaning no overburdens. We are not moving rocks. We are not crushing rocks. So meaning for energy is very valuable recovery. So this technology will use, I said, a little bit for the copper, but must be the deposit must be very special because it must be porous somewhere, because the solution is circulating in sort of sandstone or not consolidated sandstone or sand. So for the copper is generally rocks, and it's difficult. It must be fractural and so on. It's only limited used.
Thank you. We have one more question online for Mark. Take the one online and then another. Mark is asking, is still Russia doing the enrichment for France and others?
Sorry?
Is still Russia doing the enrichment for France and others?
No, we are not using. No, we enrich our own product. We have no contract with Russia, not anymore.
Okay, we're gonna have one last question for the
to you.
And then we're going with the next talk. And if you have other questions, I hope we can talk to you.
I can have a question for myself if you want.
Thank you, sir. It was a great presentation. I'm Ferdous. I'm from IFP school. So I wanted to from IFP school.
Okay.
Student. So I wanted to ask, since you said that you had you covered the entire life cycle of uranium. So I'm interested in what challenges you have in the management of waste at the end of life, how sustainable it is. So that's my question.
Okay, so you have two kinds of waste. That's been uranium mining waste and nuclear waste. We have to distinguish two different things. One is natural, and the other is synthetic one. For the uranium waste, the meaning is tailings. It's a radioactivity inside. So we developed since now 80 years of experience, area where we can fix this radioactivity in order not to go in the ground or not to go in the aquifer. We put a barrier and so on. So we are managing that, and we are controlling that on the 250 site I told you in France. It's perfectly controlled and it's fixed. For the nuclear waste, you have to imagine the size is ridiculously small. So France is producing nuclear electricity in the 60s. And all the waste of France is on the in the building in Normandy. At the surface is roughly one soccer field. It's very small and it's very concentrated and protected. Is encased in the special steel. Inside is vitrified, so we use a special glasses in order to resist the radioactivity and to stay for 10,000 years. And then after we can put that on the ground. So the idea in France is to develop a repository at 450-meter deep in a layer of shells that's old of 150 million years. And what's mean 10,000 years? At 400-meter deep and in the layer of 150 million years, meaning nothing. The radioactivity will not move. As a geologist, we know that it will not move.
You hear me? Yes. Okay, so moving on to our next speaker, Romain Millot. Thank you so much again for joining us from Lithium de France. Romain is a scientific director at Lithium de France. He has a PhD in isotope geochemistry from the University of Paris, 7. He graduated in 2013 from the Orléans University with the research management certification. He is expert in geochemistry, water-rock interaction, and geothermal waters. And Romain published more than 80 scientific publications. Great job there. Thank you so much again for joining us, Romain.
Well, good evening, ladies and gentlemen. Thank you so much for this invitation and for giving me the opportunity to introduce Lithium de France, which is a startup company, and what are our business model and what are the goals of development we have in mind to produce both heat from geothermal wells and also lithium. So I will give you a brief context, what is the state of the art for lithium within Europe and in the world, and then I will move to the concept of Lithium de France. So you know probably pretty well the periodic table, and maybe you don't know that lithium is located in the upper left side of this periodic table. It means it's a light element. And lithium belongs to the alkali metals group. And at the end of the 20th century, it became really important in different materials and different industrial sectors. And it's mainly used nowadays because of its high electrochemical potential for the production of batteries. Well, there is two main traditional source of lithium around the globe. The one is coming from the evaporation of salt and salars and also brine, and the other one main source is coming from rocks and mainly spodumene. And there is different sectors of uses, for sure energy storage, the mobility sector for both vehicles and vehicles, and also consumer device. But there is also small application of lithium in different aircraft industry sector and also grease from the industry. So having seen that, these graphs show you that the demand is exploding and it increases a lot. It is mainly due to the production of lithium-ion batteries for electric bicycles, but also for e-buses and e-bikes. And it's also used in the domain of renewable energies for the storage of this energy, and it will increase a lot. This is a very important graph taken from a recent report from the International Energy Agency, and it shows you what is the need for different metals, strategic metals, from now 2020 to 2040, following different SDGs for scenario of sustainable developments. So for lithium, the need will increase by the factor of 40, which is very huge by 2040. We see also that for graphite, cobalt and nickel, these factors are around 20, which is also very important. And for the rare earths, it's about 7. So let's just keep this a number in mind, a factor of 40 for 2040. Well, following that, you can see the evolution through time of the lithium production coming from the different main countries, from Australia, from Chile, from China. I don't want to detail this graph a lot, but I have another slide to explain the different sources. The first traditional sources, as I mentioned before, is derived from the evaporation of salars, mainly located in South America, in the ABC triangle for Argentina, Bolivia, and Chile. And you can see these ponds for evaporation. It takes almost 8 to 10 months to get battery-grade lithium deposits, and also the evaporation of water is very important, and it's lost into the atmosphere. The other production of lithium is derived from rocks, such as pegmatites and granites, and the main mineral having high level of lithium are spodumene for pyroxene, but also petalite and lepidolite for micas. So this is the main traditional source. In this framework, we can ask about the impacts of this mining industry, traditional mining industry, in terms first of CO2 emission, which is really important, carbon footprint, but also about water consumption in the different methods of extraction, refining, and so on. But when you have implementation of industry, you can also mind about biodiversity preservation, and within the use and the exploitation of industrial complex, there is also different factors like the land use, the reagents consumption, and also the waste generation, which are also key elements to take into account within your whole impact and the whole budget of your industry. Well, having seen that, there is a non-conventional resource, and I will talk about now about geothermal brine. So this is the concept of Lithium de France, and you have this 3D diagram. You can see there two wells, one for production, one for the reinjection of the brine. There is first a geothermal plant, and the idea behind is to extract heat from the ground and connect this calorie to end users in a short cycle. So it's very local for the territories. Coupled to this geothermal plant, you have the DLE unit, meaning direct lithium extraction, and we are working on to optimize this process to get better yield and lower impact. And after this direct lithium extraction process, you've got an brine enriched in lithium chloride, which means to be refined in a refinery plant, either to produce lithium carbonate or lithium hydroxide, depending on the use of the lithium ion battery. Well, where are we located? We are located in Alsace, northern Alsace, at the border between France and Germany. And this geological context is the formation of a rift, and you have natural fault with the long circulation and pathway of water generating deep geothermal brines. And in this context of the upper Rhine Graben, we have also favorable temperature, which means that it's the best place to exploit both geothermal waters and also lithium from the brines. In this map, I'm sorry, it's a little bit confused, but I don't want to go into details. It means that there is different license to operate, which are delivered by the different section of the ministry, either for the energy, for the geothermal energy, and either for the mine industry for the lithium. And for Lithium de France, we are located in the northern part of Strasbourg for les poteries and les sources. So it's a double asset because we have to exploit the geothermal water for both heat and both lithium. Well, it's a win-win situation, as you can understand easily, and we have the production well. The heat is extracted and distributed into a network. I will go back later about that. And from that, there is a loop using direct lithium extraction through a refinery to produce high-grade battery lithium salt using this lithium conversion procession. And then this water depleted in lithium is reinjected into the ground to have a loop for the geothermal brine. So in this context, lithium is of geothermal source, having low environmental impact. It also reduces the soil artificialization. It also limits the water consumption because we are working on a loop. There is also few material used and low greenhouse gas emission. So it also contributes very in an important way to the industrial response to the issue of national French and European sovereignty for lithium supply. And the other part is the heat that can be produced and used directly to the territory. This heat energy is local, continuous, renewable, and also that can be used for different purposes, either for industry, either for district heating, and also for farming or different greenhouses or recreative facilities. Well, this is a complex cartoon, but just to mention that we are currently working on the downstream process. I mean, after the direct lithium extraction, the refinery part, which is really important. As you can see, there is a number of steps: neutralization, impurity removal, concentration, polishing, and so on. And then at the end, you have two ways: either to produce lithium carbonate and either to produce lithium hydroxide, depending on the use of this lithium for the battery type that you have in mind. At each step, you have an impact, CO2, water impact. So we have working pretty hard to optimize this process to reduce this impact, and we are using life cycle analysis and also different software to be able to optimize this process, which is really important. Well, that's bring me to the end of my presentation, and I will run over the key points again. So I hope that you understand that there is a lot of challenges and issues related to lithium production, either ecological, economical, and also about sovereignty of the lithium production in France and also in Europe. And there is a good opportunity to develop what we call a geothermal lithium industry ecosystem in France and also in Europe by different ideas and possibilities. And there is also drivers remaining of growth, the technological developments, innovation, technical challenges that can optimize the different processes. I didn't talk about the recycling sector, but it is really important. When lithium is produced in Europe or in France, we have to build the facilities to recycle all these critical materials. And recently, the Critical Raw Material Act act is promoting the production, the refining, and recycling of the different raw materials with the different threshold at different time steps. And last but not least, we are also working in the framework of standardization, which is really important for quality and safety of the different products, but also for sustainability and also for responsible mining concept for this mining industry and for the lithium production. So thank you very much, and I hope that you will have some questions. Thank you.
Thank you so much, Romain. That was a really good presentation. Yes, we do have some questions here.
It's just a quick one. How many geothermal doublets do you have?
Oh, yeah, good question. No, we have a timeline, and hopefully we expect to drill the first well next year because it's a long process, permitting licenses and license to operate. So we hope to drill the first well next year and test it, and then we will have probably a couple of months after the first doublet, and we will test this production of both lithium but also water, which is important because it's a combination of lithium concentration. We know that this area is favorable in terms of lithium, but we have also to achieve a certain level of cubic meter per hour of water production.
Which just really leads on to my second question, which was about if you have an open loop geothermal system, you need to, as you'll know, you need to have enough time for your water to be, your brine to be reheated before you extract again. Obviously, it's not necessarily the same molecules, but you know, you can't do that too fast. Is the amount of time you need for your cooled brine what I'm getting at is the dissolving of the lithium in the water and the heating of the water for the geothermal? Are the two things compatible?
Yeah, it's a key question. So that there is project going on about that, about what is the effect of the rejection of the depleted brine and cold, and it depends on the location of the doublets and the connection in terms of faults between these two doublets. And there is a recent paper from a German group showing that there is no matter about heat regeneration, and probably the decrease of lithium in terms of regeneration, redissolution, will happen after 10 or 15 years. But it's the first order of estimation. We are currently working on that because it's a complicated system. We have to model using transport relative model, and lithium production and regeneration is a balance between dissolution of primary minerals, but also precipitation of secondary minerals. So it depends on where is the main source, either the granite basement or the Bunsenstein layer and the different mica minerals that can be redissolved and so on. But it's a key question, and it's really important to have the order of magnitude of lithium durability of extraction. You're right.
Yes. Hello, Romain. My name is Guillermo Pérez Drago from Basic Front Lab, project manager. So thank you for the presentation. Very interesting. I have two questions. The first one, it's more technical, more you as a geochemist. This the same thing what you were mentioning right away. It's is there already like a consensus of what's the source of lithium, rather of water rock interaction between granite or the sandstones with mica, white mica, or I've seen some papers from the BRGM talking about this, but is there already a consensus? And well, maybe a second question after.
Okay, the upper Rhine Graben is really heterogeneous from the northern part to the southern part. And where we focus on the northern part, we have a good idea of what is the source of this lithium from the brine. We published a couple of years ago a paper with different data about geochemistry, thermodynamics, and also geology. And it's a mix between, let's say, a primary old seawater that is also diluted by waterwork interaction and also meteoric water. So it's complex, but we have a good overview of what is happening at the regional scale. When you are looking at the local scale, it's more complicated. So this is the reason why we are performing seismic exploration to have a better view of what is the structures in terms of fault, so to better place and the wells to be able to de-risk and to have the best production of both water and lithium as well.
Well, if I have more time for the second question, it's more related for economic point of view. You are in the lithium industry. What do you see it could be the risk for lithium exploration, I think in Europe, related to the solid batteries, battery solid, that we hear a lot about this new technology of batteries that need much less lithium than natural battery.
Yeah, I mean, for the moment, there's room for every types of batteries. It's a very complex market. There is NMC, LFP, but the gigafactory that are now on track are installed to be able to produce both NMC and LFP batteries. And I don't know what will be the future, but we can imagine that a diversity of battery types will be probably the best solution. A mix of for energy storage, for mobility, and so on. And also, it depends. But lithium will be also definitely a key element.
Great, thank you so much. We're going to take a question from Teams really quickly.
In fact, you mostly answered the question. The question is from Laurent Chorer. Do you know where the lithiums come from in the geothermal brines?
Yeah, it's coming from primary old seawater and also waterwork interaction, old and current waterwork interaction. But it's more complicated on the south part of the upper Rhine Graben. But there is also research ongoing on that. And there is one project research funded by the National Research Agency in France, ANR, to combine different approach, both modeling, geological and geochemical approach, to be able to see what is the main source of lithium and how long we can use these doublets to produce both energy and lithium.
Sorry. Are you only considering lithium in the geothermal water, or are you looking as well what other metals or species you could find in the brines?
Good question. For the brines in northern Alsace, we are now focusing on lithium because this is the most ready technology for adsorption, but there's also different ion exchange or solvent extraction that can combine their production of other critical elements. But it's not on our roadmap for the moment, but we are thinking about that. But each brine is
exploiting them, or just at the beginning, are you considering of analyzing the brines to make sure you know exactly what is the full spectrum, and then you decide to move on the for the economical reason you go for lithium, but at least you know what is in the what are the elements in the waters?
We have a good overview of what are the chemical composition of the brines around the world. We do make a compilation of all the data, and there's several people dealing with that. So it depends on the context, geological context. pressure, temperature, and lithology, and so on. So each site, it's different. So you cannot adapt a technology of extraction in northern Alsace or in Salton Seas. It should be different. So, but we are definitely thinking about new products or byproducts to the risk and reduce the cost of operation.
Thank you so much again. Great presentation. We will be taking 5 minutes break before we move forward for the upcoming 2 presentations. So if you want to go take a break here, feel free. Again, we will reconvene in 5 minutes. Okay, teams, we are back online.
Yes.
This one is- But then you will have to switch. Okay. Everyone is ready for the next two topics? Yes, okay. Thank you so much for joining us today, Jérôme. Jean-Jacques?
Jean-Charles.
Jean-Charles. Yes, sorry about that. Hey, can you remove that little... Okay, so Jean-Charles is a geophysicist from UPMC, Paris. He's a geologist from Bordeaux, 1988. He spent quite a bit of time during his career at CGG, as you guys can see, joined different roles and started with seismic processing and then moved to a field geophysicist, technical supervisor, acquisition, salt imaging. And then his last role at CGG was the VP Technology Sales from 2010 to 2019. Since 2020, Jean-Charles is the co-founder and the president of Geolinks Services. And Jean-Charles, I will let you take over. We're going to move to your slides in a minute.
C'est ça. Thank you, Ayet. Good evening, everybody, online and on the floor here with some beverage not far. Sorry for the online guest. So I guess I can start. Yes? Okay. Everybody's okay online? Okay. So this is the fourth talk of tonight. Thank you for the IAG local chapter Paris for this great organization and for the very nice team and very energetic team. Thank you for that. So thank you everybody for attending tonight. So we are going to talk about geophysics a bit in innovation for the raw materials. This is my mission tonight. And I'm going to talk about a specific geophysical technique, which is not quite used for industry right now, even if there are some actors on this. But very promising, I can tell you that this type of technique, which is called passive seismic, is going to be used more and more because it's a very cost-effective and a very useful geophysical technique for various subjects. So here we're going to see about how it can be used specifically for the mining, but not mining exploration here, but more mining exploitation and risk mitigation for mining operations. So again, my name is Jean-Charles Ferran, the president of Geolinks. And Geolinks, will tell a few words about Geolinks, and when I will introduce that. I'm the president of Geolinks. It's a startup, so it's a young startup, and we are what we are doing in Geolinks. We are doing geoscience, as you understand, and we are delivering monitoring solutions actually for a sustainable future. And just a few words about Geolinks. It's a small team at the moment, 10 persons. But it's a good opportunity for me to say that we are recruiting. So for more people, so please do not hesitate. If you want to join this nice adventure, our DNA really is the passion for innovation in geoscience. We are focusing again on the monitoring solutions, delivering monitoring solutions. And okay, we are based here in Paris for the co-founders, but our research and development group is in Nantes, west and part of France. As an introduction, before I talk about more geophysics, I like to remind me every day, or at least sometime, that my role as a geoscientist can be quite important actually, because I can influence more than 50% of the decarbonization solutions we need to achieve
until 2050. Why? Because if you want to, for example, if you want to decarbonize the big industries like cemetery and things like that, you need CCS, and for that you need geoscience. Okay, so if you want to switch from fossil energy to hydrogen, you are going to need to store this hydrogen at least 15 to 20% of the yearly consumption, and for that you need geoscience. If you want to develop more the renewable, and this is the topic of today, you will need to have raw materials, you get it, that, and you need to extract and process the waste and tailings in a sustainable way, and for that, again, you need geoscience, not only for exploration. So it's more than 50, it's 54% actually of the technology that are being used for decarbonization, where the geoscientists as a whole. So that's why there are so many young people now joining the geoscientist community, and I'm happy for that. If I'm here, is because there is a problem to solve, and when we started Geolinks, we considered that, okay, we have different problems to solve as a community, and in Geolinks, here, regarding raw material, we consider that, okay, it's more than 100 years, and more than that, of course, but we're doing intensive extraction of raw materials. Our benefit, of course, the benefit of the human beings. But now it's more than 30,000 sites of waste and tailings all around the world. And you have between 2 and 3 major accidents every year. There is one example here, Brumadinho in Brazil, a recent one. But so the monitoring is, of course, a regulatory obligation for the mining operators. Of course, it is. They do everything it's possible to avoid that. So the question we can ask, and the question we ask for ourselves in Geolinks is, okay, what is missing today to avoid, or at least to better prevent those accidents? So just to give you the idea, how we monitor, for example, the tailings today, our mining operator do that. He's going to use a lot of techniques that are available. So I just mentioned a few, but there are some surface sensors like extensiometer, tensiometer, piezometer. You are going to use satellite imagery. You are going to use LIDAR. You are going to use visual inspection. All those things, you are going to do it to prevent accident, to monitor. So when you do that, this is what you are monitoring actually. You are monitoring the very shallow part of the tailings. But it's the cause of accidents, maybe they come from somewhere deeper, the water infiltration, these kind of things. So actually, a large part of the things are not monitored today. And this is where the geophysics can bring some help, hopefully. And this is what we are working with in Geolinks. So the idea is really to look at the more deeper cause of a future accident, just to prevent him. And for that, you are using simply a sensor, as you see here, and I will tell you a bit more about that just in the next slide. So the idea really is to monitor here deeper in the tailings, as well for slope stability in the open pit mines. Okay. And so it's for that we are using passive seismic. So I introduced that term, and I will tell you more just after. We are using passive seismic. This technique is quite cost effective, and because it's quite effective, it's very low CO2 footprint services. Okay, the lowest one you want to monitor today. So let's see how it works. The idea really is to see where it's stable or where it's not stable. Okay, what is moving, where it's not moving, where it's going to move. A few words in geophysics about passive seismic. Passive seismic, strangely, it's a geophysical technique, and it's passive because there is no active source that we use. We use only something free that is propagating under a fruit, is the ambient seismic noise. This is an example of record of ambient seismic noise. So for the non-geophysicists, it's just something that travels under your feet every day. It's free of use. So this is where the geophysicists are coming. So ambient seismic noise is a big hub, like in in a conference room in a coffee break. It comes from all the source of noise, natural and anthropogenic. But at the end, you have this noise. So what can we do with this noise? This is where the geophysicist is coming. We have some plenty idea. And there is a specific part of the passive seismic here where they use the noise to recreate a seismic experiment. Okay, so they are to reconstruct a wave which is propagating under our feet. And how they do that, the geophysicists, they need at least two sensors, here geophone 1 and geophone 2. With these two sensors, we measure just noise. There is nothing to really very interesting in the noise itself. So you need to do a mathematical operation, okay, to extract something quite interesting, which is here below. Is the seismic wave field that propagates between the sensor 2 and 1 and vice versa. So here you have something quite interesting. From a random noise, you have created something which is a scan of the subsurface. And it scans every second because it's quite fast. Okay? So the idea is, how are we going to use that? Oops, sorry. That's not there. Just to show you the wave field that is reconstructing this one. It's a scanner, okay, that scans the area at all depth, from the shallow part to the deeper part. It's up to the geophysicist to use it as he can. So now, can we use this scanner of the subsurface for mining activities? So here again, the subject is preventing mining risk. Okay, so the idea is going to check the subsurface every second. But in fact, we're going to reconstruct a measurement of the area between two sensors every day. And what we are going to do every day, okay, we are going to compare one day with the other one. And when you do that, you are particularly being able to measure some variation of velocity propagation at the place where you have put your two sensors. And this is what you are doing here in the right part of this slide. So you have put the sensor here on the left part. You are measuring every day, and then you see the difference, you measure the difference. And this is what you are going to use to give useful information to the mining operator. When we do that, of course, we do that not only with two sensors, but we install a network of sensors for the mining operator. And we don't use large network. It's 10, 20 sensors over the area. It's a quite effective method, okay? Because we correlate with 10 sensors, you create 100 monitoring points because you correlate the different sensors. So it's quite powerful. And this is what you can provide with the operator at different depths. You are going to tell him, here it changed, here it's stable, here it changed. Up to you to interpret at the moment and to take the measure you want to take. So this was a recent example we've carried out in the largest open pit mine for diamond extraction in the world. And so the technique was tested from the operator. So now we are running into a phase of putting a long-term monitoring on this open pit. So this is to give you an example, okay, of how it can be used in practice. So I think I can conclude here. Okay, just remind you that here we are talking about the geophysical technique, okay, that use the ambient noise, which is free, to transform it into a monitoring system. And you do that for what? To prevent the risk of a mining operator, okay, in tailing dams or in slope stability in the open pit. So it's quite convenient for the operator, and again, it's the lowest CO2 footprint emission as a monitoring service. So go for it. Thanks for your attention.
Thank you so much, Jean-Charles. That was great. Any question from the audience or teams? People online? Yeah, go ahead.
Thank you for your presentation. Actually, I'm new to geoscience. I'm wondering what kind of information can you get with this kind of interferometry?
You are a geoscientist or you are not a geoscientist? Sorry. Okay. That's I understood previously, yes. What kind of information? So actually, you can extract two kinds of information. An information about the change of the structure of the rocks. So if you have some fracture appearing, things like that, okay, you're going to be able to detect that through the velocity variation. Okay, so that's the first thing. And the second thing you are going to extract, and this is where Geolinks is working on it. I didn't show that, of course, but it's the water infiltration, so the fluid movement. Okay, and this is a second type of information that you need to extract, and you use for that specific property of the waves, which is the attenuation. But you are going to as well provide the information about fluid movements, water infiltration. So this is the two types of information, at least.
Hi, Jean. Thank you for your presentation. Very interesting.
Thank you.
About the projects you're carrying out at least in France? Do you have some projects here in France, or where are your projects right now? I haven't seen your presentation yet, and you were in Ashnet last week, right?
Yes.
For the natural hydrogen. Can you tell us a bit more about this Geolinks for the mineral exploration and for hydrogen as well?
Thanks. Thank you very much for the question. It's true that I was at the Native Hydrogen Conference last week. Because of what? Because passive seismic and the technique we are developing in Geolinks can be applied for very different applicative markets. So we are applying our solution for underground gas storage, hydrogen storage, for CO2 geological sequestration. We are applying that for mining risk prevention, as you've seen. Okay, but you are applying that as well for non-carbonized resource exploration, like native hydrogen, like helium. We have worked for 45 Energy, for example, for helium. We plan to work, and we have some discussion with TLS, with Lithium de France, and with some other operator in France, TLS, to use that as well for the brine, okay, and especially the temperature effects of the brine in the loop, this kind of thing. For water as well, management, okay, you can use this technique. So plenty of market where you can use this type of technique. Thank you for the question.
Okay, it was really interesting. I have a question regarding which is the initial data information that you need to have from your client so you're able to do this study. I mean, do you need the initial velocity model so you can convert this time shift into a velocity variation? What do you need to start the project?
You don't need so much actually. You don't need really. Yes, you need some velocity that you can get from the geologist on site. So there is no issue on that. This is mostly the information you need. Much more importantly, is what you need during the monitoring. Because during the monitoring, the information we are bringing is one information. Of course, it's quite interesting because it comes from a different space of the other monitoring system. But you need to correlate that with all the other monitoring information, which is available and from the other monitoring system that the operator use. And this is where it's quite important. You need to correlate this new information with all the other information, okay? And even with the weather information, because you have some effect of weather that you need to decorrelate, for example. So you need a lot of other information, and it's very valuable for the mining operator at the end, okay?
What is the minimum kind of time spaces that you can use to monitor? Can you monitor each one? You do monitoring each year, which is the kind of the minimum period?
Minute, actually, okay, most of the time. After it depends really on the type of industrial noise you have. So what we do usually for any kind of, it's 1 day, okay, which is already much more than needed in some industry, like in CCS, for example, or in underground gas storage. They don't need that every day. But we can technically reconstruct most of the time, every day, okay.
In the example you used up there, you had 2 monitoring stations, nodes or whatever, on there. Is that typical, or do you use larger spreads? And if so, do you do 3-dimensional monitoring as well as 2-dimensional?
That's right. Actually, you use that in a network. Yes. So 2 sensor would never use that. There might be some post-mine risk mitigation, and we have some discussion going where you can use very, very small system like 2 or 3 sensors, okay, just for a very specific area. But generally, we are using a network, of course, because what you need is to reconstruct a volumetric information. So it's not anymore a 1D information. It's not a 2D information. It's really a 3D information, like you did seismic monitoring. Actually, it's very, very similar.
Do we have any questions on Teams? Sorry again. Okay. Okay. What about Teams? Do we have any questions on Teams? No? Okay. One last question.
Sorry for being so small. Thank you for the presentation. Okay. What are the main locations of your clients? It's in Europe or Canada, North America, or maybe South America, where we have, well, I'm from Peru, so we have a lot of problems about exploration. So they literally kill our ecosystems and then they find the metals that they aim. But this is a great solution for implemented there.
Okay. Thanks for the question. We are a startup, and we are a deep tech startup. We started in 2020 with a patent from the CNRS. Okay. So at the moment, we are still in the development phase. Okay. So we are launching our first minimum viable product service next year. Okay. In mining and in native hydrogen exploration. We have a plan of 2.5 year development for the other markets. Okay. And so at the moment, we are working with 10 different clients, but the clients we are working with, they are helping us in developing the solutions, the different markets. Okay. So it's more partners than clients at the moment because the technology still needs to answer exactly to what they need, the decision they need to make, and so on and so on. So there are still some work ongoing, but the essential is there. Yeah. Thank you for the question. Yeah.
Great. Thank you so much. Thank you again.
Thank you, everybody. Thank you.
Our last topic of the day. Center of the day. Thank you so much for joining us. And we come back to the services service, which is a political venture science associate at Harvard. We take entrepreneur, turned investor, and expert in climate tech, critical role in organization. Thank you again for joining us.
Thank you for the invitation.
That's okay.
No, what? You see that I have a very ambitious title for the talk, which is called Marbled Role in the Critical Energy Transition, in the future of the energy transition. Full disclaimer, I just made the slides today, so I'm just seeing the typo right now as we speak. But I used to be a deep tech entrepreneur, so it's really nice to have had the chat from Geolinks and hear about the deep tech entrepreneurship that's happening in geosciences right now, especially given the climate crisis and the energy transition goals that we have. And I'm really excited to tell you more about what we're building at Marble and what we've been doing so far. So Marble is a venture studio that's based in Paris. We're also 2 years old. And we partner with scientists, engineers, operators to build deep tech startups that have the potential to slash emissions, remove carbon from the atmosphere, oceans, and anywhere else where it's having a net warming effect, and then eventually for the goal of cooling the planet. I recall I don't have the IPCC slide on what the scenarios for energy transition are, but we definitely need to do a lot more, not only on critical minerals, but also on carbon removal, decarbonization, energy, all of these spaces which we work on. Typically, our process is when we partner with a scientist or an operator who wants to build a company in partnership with us, it's a 9-month process. It goes up to 12 months sometimes. And the first 3 months is called explore, when the potential founder comes in to explore multiple ideas within what is called an opportunity space, which I'll tell you about in a bit. And that could be limited to an industry vertical, a sector of an industry, or it could be a technology that they want to explore in commercialization. I think we have founders who are looking to commercialize plasma-based technologies, for example, or electrochemical technologies to see where they could be applied in the sphere of climate. But we also have founders who are particularly looking within the critical minerals space for climate. Once they found the best idea in the first 3 months, they'll turn the best idea that they found into a company. And typically, with the support of Marble, in ideation, risk analysis, techno-economic analysis, finding a co-founder, advisors, a patent support, all of these things come to mind. And this is typically the longest process also, because as some of you know who've built and grown teams, it's the hardest part is hiring the right person and meeting the right person who comes on board to build the company, but also making sure that all the puzzle pieces sort of fall into place. So you can then do step 3, which is take your startup into the world, which is when Marble becomes the first investor at pre-seed in the company, and we typically invest 250,000 euros as a pre-seed investor for 20% equity. Some of our startups have gone on to raise additional funding from other investors immediately. We also support our startups with a network of investors who are interested in supporting new innovations in the field of climate tech, but I'll talk about that in a bit. So this is our journey so far. We were launched in September 2021. We're backed by top climate tech investors themselves, both throughout the EU and the US. Our objective is to build 25 companies that are focused on deep technical breakthroughs, and that can have an outsized climate impact across the various spaces I was just telling you about. We have the equity value business model, which I just told you about. And up to today, we have 4 funded companies. Actually, since today, we have 4 funded companies because we've just spun out a company doing stimulated hydrogen with the first geoscientist company that we've spun out. So I'm particularly proud of that. And several of our companies have gone on to raise external funding or are in discussions to fill in their term sheet to raise external funding. We have several projects in the second phase of our program as well. And in general, we're quite recognized in the climate tech ecosystem among investors, among builders, in universities, but we're also trying very hard to create a presence because it's only been 2 years since we exist. And yeah, we still have a very ambitious objective in front of us. So this is our goal. I'm going to briefly go through this. We're a climate specialist. We make talent meet opportunity. So we find the right sort of person to come and build a solution in the space that we've identified for them. And this is a process that we call reverse tech transfer, where we identify the opportunity for example, a geoscientist to come and work on and build a company in. And then we have aligned incentives for that person to come and build the company. So not only the pre-seed investment, but also a stipend throughout the duration of the program, whether that's 9 months, 12 months, or a bit later. So this is the Venn diagram that shows Marble is essentially where hard climate problem meets deep tech, white space, and a massive market, which we can assume that we have for climate. So these are our 6 focus areas, as I was telling you about before. Critical minerals is a big one, and I'm going to give you like a brief snapshot of what we're working on. But besides that, we're also looking at energy, industry, agriculture. Carbon removal is pretty big in our portfolio so far, and we have a few geoscientists also working on that, and climate adaptation in the case that we don't meet our net zero goals. So those are some of the areas we have in focus. And right now, to go deep into the critical mineral space, which is what I'm here to talk about. As some of you might have heard, I'm not a geoscientist myself. I'm not a geophysicist, but this is an area I've been researching for a few months and looking into because this is quite relevant for climate tech applications, specifically for battery minerals, renewables, and power grids. And if we're able to power anything that will help us cool the planet, we have to use clean energy. And that's where critical minerals come in. And that's how we realize that a lot of primary supply is needed very fast. Even though recycling and maximizing sort of efficiency of already existing mines can be helpful. Yeah, there you go. So you still have a supply gap of several thousand megatons, I think, specifically in the case of copper, which is the backbone of the energy transition, but also across all the minerals. So either we have to create new mines, which obviously takes time. There's a very long lead time for creating new mines, or we have to build new refining capacities or more effective refining capacities. Typically, for copper, it's 17 years. And I know that recently in Indonesia, there's been a mine that opened with the shortest lead time for nickel, I think, which was 4 years. And things are changing, but we also want to make sure that you don't take any unwarranted risks. So we're also quite keen on building refining capacity. Another pressure for building something in this space comes from geographical concentration and major supply constraint risks. And that's something we've been hearing about since early this year. You can't really control where you mine the minerals, and that's mined across the world pretty much, a large part in China, but also in some other countries. But a majority of refining is actually concentrated in China. And because of very strong policy push in the EU as well as the US, we've also been exploring building better refining capacities in the West. And specifically for minerals that are relevant to the energy transition, of which I think there are 6 that were outlined in the ETC report: cobalt, copper, graphite, lithium, nickel, and rare earths. Rare earths are just a group here. You can tell it wasn't written by chemists, but I think what they mean is neodymium mostly. So yeah, I think there's a massive opportunity to diversify supply. It doesn't really come mostly from identifying new reserves or mining, sort of setting up new mines, but a lot of it can also come from improved refining. We've also identified other challenges, having spoken to people investing in the space or people trying to build in the space or long-term actors, which is a big part of which is a local water stress. I think someone highlighted that in their question just now. Effect on the local ecosystem, pollution, waste management, but also mining is extremely water intensive, and that's a big climate problem. So we're also keen to innovate in that space. High capex and insufficient financing to set up new mines or even refineries, as well as building social acceptance and reducing the emissions of the industry. So far, we don't want to spend more energy and burn more fossil fuels to make more minerals. It's a catch-22. So this is the slide that summarizes our mineral focus. I'm not sure how much in detail I can go, but I'll try my best. So these are the minerals that we focus on the most. We've been looking quite a bit at copper and neodymium because they're quite relevant. There's a huge white space in innovating in that space, and particularly for exploration. There's quite a bit of opportunity in identifying new reserves. Comminution is something we're interested in, not just for the critical raw minerals thesis, but also for the geochemical carbon dioxide removal or any sort of geochemistry-based thesis. So if you know a great way to crush rocks that consumes less energy than it already does, it's super exciting to build a company in that space right now. Extraction from low-grade ores using acids, solvents, surfactants, bioleaching, electrochemical techniques, or even like less comminution. This is interesting for us because I think mining produces 72 gigaton of waste every year. So we also have to find a way to do something with that. Extraction from unconventional resources, brines, tailings, in situ mining, that's also interesting. Refining, making it more efficient, clean, and relocalized. So plugging it into a renewable grid, that's something that we're excited by, but also less energy intensive refining, for example, for rare earth minerals, which takes more than 100 steps today. So that's something we're quite conscious of. Recycling of copper in particular, because that has the highest sort of, there you can have the highest margin to push in terms of impact and innovation. There's a lot of copper that we already use that's wasted and not recycled. So there's something interesting to do there. And then substitution, because unfortunately, a lot of graphite is mined in China today. I think 98% is mined in China and refined in China. So it's becoming increasingly important to increase the supply also in the West. And you don't have to necessarily create a new mine. I think a lot of people are looking at alternative chemistries for battery materials, specifically synthetic graphite, as well as for permanent magnets, anything that doesn't use as much rare earths or uses less of them. That's also quite interesting for us. If you have further questions, actually, I'm available right after this, so I'll be happy to chat more with you. And to conclude, we're hiring founders and advisors who want to help us build the next generation of critical raw minerals startups that are based on science and that help move the needle to help us achieve our net zero goals. So this is the opportunity that you'll find on our careers page, careers.marble.studio. That details a little bit more what I was just talking about. And another thing that I didn't touch upon much is hybrid approaches. So anything that touches on existing infrastructure for energy is also quite interesting for us. If you have a background in geoscience, geochemistry, geophysics, or if you have a mineral processing background, or you're keen and interested to get in the space, not only as a founder, but also as an advisor, please reach out and get in touch with us. We're really, really excited to speak to you. And thank you.
Thank you so much, Lipsa. Any question from the audience?
Thank you very much. That's a great project, Marble. And so I was interested to understand how you help these founders that bring the project or bring the idea. How do you do that practically?
That's a great operational question. So typically when we start working, so founders who come to work with us, you can divide them into three groups. Either they come to us with a TRL4 project or a more advanced project that they would like to commercialize. There are some who have deep sector knowledge, but they don't know what they want to build in the space and what they want to commercialize. And then there are others who are just sort of finishing their PhD and they have a lot of like great scientific concepts, but they need more steering to understand what's interesting to build in what space and how they can use their skills to build a company in that space. So depending on which category the founder falls in, we sort of personalize our support to them. And typically, ideation is a big part of that, especially for an early stage company. And within ideation, you can also have sort of external engagement, outreach to other advisors in the space, other thought leaders in the space, investors in the space who are looking to sort of allocate funds. But that could also mean doing like a lot of whiteboarding and brainstorming, deep technical analysis, comparing technologies one against the other, just finding out the right metrics that you need to hit to succeed and build something great in the space. And yeah, eventually, I think a lot of it is, you can think of it as mentorship and coaching that helps them become good leaders in the field that they want to enter and making sure that they have the best chance to survive and thrive there. Thank you.
We do have another question here. Yeah. No? Okay, great. Thank you so much again.
Thank you.
Appreciate it. And while we are putting together the final slide, please welcome me here, the EAGE chapter members and the SPE member here with us, Guillaume, who else? Soraya, everyone from the chapter, please join me here, because it really took a lot of time and effort to put this presentation together, or this day together. So I really appreciate you helping us with this process, and being new to the chapter. It was a learning experience for me to put together this special day. So I do want to thank every member of the team here for their hours of working and their effort in gathering all the technical speakers and being here with us today. And then I do want to thank also all the speakers for taking some time of their day and joining us today. So thank you so much. Please join us here too. We would love that, because we'd like to take a picture. So if you don't mind, take a picture. Here's somebody to take a picture. Do you mind taking a picture?
Yeah, but you have to
Squeeze all together.
Yes. Cheers.
Okay, great. Thank you.
Thank you.
Thank you for all of you who joined us today in person, and then people on Teams. Again, thank you guys for joining us today. We have a lot of topics coming up in 2024. Some of the topics are summarized here, but we are always looking at finding more speakers, more topics to present on. So if any of you is interested in representing your company or the project that you're currently working on, please reach out to us. We would love to have you as one of our speakers for 2024. We're actually putting together the calendar for 24 right now. So if interested, please reach out to us and we will add you to our schedule. We would be glad to have you as a guest. SPE, Natalie, do you want to add something?
For some evidence, but in reality, the energy transition today for any oil company, it's the biggest challenge, because everybody become energy producer. So energy is not only oil, gas, and nuclear, also the waste recycling. I'm represent the Veolia, so a recycling company. Also, we can talk a lot about battery recycling and all other metal recovery and second life, and how we calculate this famous CO2 and avoided CO2. So there are a lot of things to discuss. There are no today one alone opinion about how to deal with new energy and how to resolve all this challenge. So we invite everybody to think about it, also to participate, and please take the micro and discuss. Feel free to discuss with everybody. Especially you are young, but you are not. We are all there to transfer to you our knowledge and let you resolve our today problem. So so that's the reason why we are happy to have young people in the board. I think very, very good job to invite also young people. So welcome and enjoy your evening. So see you next year for the new events.
Can you hear me? Yeah. So with that, we said goodbye to the 2023 year for our association. Once again, thank you to the SPE. They are always on board with everything we propose to them. Thank you, because we started the year with you. Now you finish the year with us. That's how we like to do things. And we invite you to our networking station, and you can go eat and drink. Thank you for coming, and see you in the next year. And Merry Christmas.
Thank you.